we have 3 minus 5 plus 5 and minus 8 and 0, 1, 2, 3. So m equal to 3. So we need to find out the subsequences of length C, length 3. Find out maximum product of first and last element. So if you closely see the subsequences, right? This is one subsequence. It means, what do you mean by subsequence? So it should follow the same order of elements, but it can skip the elements in the middle. First of all, so this is one subsequence of length 3. So obviously you have uh, so 3 minus 5, 5. And what we can do, so we can skip this element. So once we skip this element and we'll find these are the three elements. So this is also subsequence. We can skip the elements in the middle, but follows the same order. So it means 0 after 2 after 3. So something like this we have 3, 5 minus 8. And what we did next, and we figure out one more subsequence, this one. So we can skip this element so that you can find out a subsequence with this. So minus 5, 5, 8. So minus 5, 5 and minus 8. So we need to generate all the subsequences and of length m and find out first and last element product. Okay, so first and here in this case it is 15. In this case it is minus 24. So in this case which is 40. So we need to return the maximum out of it. So the max out of it is 40. So this is what the problem statement, right? So yesterday what we tried generating all the subsequences using recursion, right, or backtracking. It means it's simply like the subset problem. So we just taken that whenever your subset length is equal to 3, then we just store that into result. And we just find out we just find out the product and updated the max value. So that's what we did, right? Can you come up with better brute force? So this is a brute force, right? So obviously, which is going to take m into 2 power n, because m is the length of your subset size. That means length of your subsequent size. So you will look for all possibilities. Okay. Now, can you come up with the better brute force? So try better brute force. I will try to explain the optimistic solution. So let's see, let's understand the what is the problem we are doing when we are generating the subset, right? So 3 minus 5, 5, 8. So 3 minus 5, 5 minus 8, 0, 1, 2, 3, right? So m equal to 3. So if you closely see, right, when we go with backtracking, so we have generated all the subsets, but what are the valid subsets of length 3, right? So this is one valid, and we find out one more valid subset here. Some or other way, we find out the valid subsets, right? How do you find out? If you look at this input, right? If you look at this input, uh, where start will end, where the start will end, man. It means you need to generate a subsequence of size 3, right? So you have a start index and you also have an end index, right? So you have a start index, in the middle you have something, you have a end index. Okay, so first we need to see where start will end, or prior to that, where end will start. Do you get my point? For example, in this case, 3 minus 5, 5, right? It means what? 3 is a start point and 5 is the end point, right? So where the end pointer will start? At what index endpoint will start for m equal 3? Can you tell me? are you following me, or are you following me? Ajay, Kalyan, Banu. So generally we need to generate a subsequence of length 3, right? Of length 3. So for sure, the the end of each subsequence starts from here, right? Yes or nobody? If you closely see, these are the subsets we generated, right? These are the subsets we generated. If you closely see, if I copy here, where the end of the subset will started, so it repeated this 5 and minus 8. That's it, right? Yes or no? It just repeated this 5 and minus 8 for remaining two starts. So if you closely see, this is what happened, right? So 5 is repeated, minus is repeated, minus 8 is repeated twice, 5 is repeated once. Are you following me? Ajay, you are on mute, buddy. Okay, so what you need to understand here is we need to find out a subsequence length of m equal to 3, and we need to find out the max product of first and last, and product of first and last, whichever is max, which is to be returned, right? So which is to be returned. Now now one thing for sure, so what we did, so we have tried some typical brute force approach generating all the subsequences, and whenever the size subset length is equal to 3, then we find out first and last product and store the result. So now let's see the optimistic solution. So if you closely see, let me take it as a better way. So you have 3 minus 5, 5 minus 8. So let's see here what are the subsets you could see, subsequences. This is one subsequence, and let me try some other way. And you can have 3 minus 5 plus 5 minus 8. Okay, so this is one more subsequence, and we have 3 minus 5 plus 5 minus 8. So if you are able to ignore this one, then the remaining three elements are going to be one more subset. So I mean, I ignore this one so that the remaining elements are one more subset. So actually it's a typical sliding window technique, but we need to understand. So these are the typical subsets we had, right? So if you closely see, these are the typical subsets we have. 3 minus 5, 5, and minus 5 plus 5 minus 8, and 3, 5, 8. Right? So these are the typical subsets we had. And we need to, for our use case, right? First element and last element product. So only we need to worry about only what is the first element and what is the last element. The product of those two values only matters to us. We don't need to worry about other values. So whatever values coming in the middle, which we need not to worry about it. What is the first value? What is the last value? The product of those two elements is going to be our answer. So we need to return the maximum out of it. So now to do that, we need to understand where end will start. Where end will start, right? So this is the end, right? So from where in a typical subsequence, if you closely see where end will start, right? So which is more important? So if you closely see 3 minus 5 plus 5 and 8, 0, 1, 2, 3. The window size we need 3, man. Window size we need 3. So where a end will start, please. So it means what? From if m equal to 3, end will start from m minus 1 index, right? Yes or no? M equal to 3 means, so which is going to be second index. So it means From here, end will start, correct? Where start will start? Start. It is always be from 0th index, right? Yes or no? Start is from 0th index, right? Correct. So start is always from 0th index, end is from m minus 1 index. Now, now what you need to see is the start can be, so definitely we have to multiply with end, but we need to capture of start, right? So here is one start, here is one start, here is one more start, and end anyhow we have to multiply with the end, so that is for sure. Now the start, if you closely see, we need to capture minimum start and maximum start. Why? Because end can be negative. When the end is negative, if you closely see here, this is my start, right? So here 3 into 5, which is 15. But if you see here, my start is minus 5, end is minus 8. So if you don't capture what is the minimum value of the start, what is the maximum value of the start, you cannot obtain the max result. So if I am able to capture minimum value of the start as well, then I minimum value of the start as well, then whenever I get a negative value in the end, when I multiply, I can get max value out of it. So what I am trying to do, let's see here. Hope you are able to get my point. So 3 minus 5 plus 5 and 8, right? So you have 0, 1, 2, 3. So what I'll do, for sure, end is starting from here because m equal to 3. Start is starting from here. So I'll just take min start and max start. So initially, which is 3, which is 3. So now I'm just making end is I'll repeat this end until it is reaching to the end of the array. So now this is my start. So this is min start is minimum is 3 also, maximum also 3 here because I am starting from here. So this is my current end, right? So I'll just try 3 into 5, again 3 into 5. So here it will return 15, here also it will return 15. So in both of the cases the value is 15, so that this is my current max, which is 0, and current value is 15, so that I'll just update to 15. Perfect. Now I move end and start. So next iteration what I'll do, I'll increment the end, I'll also increment the start. So this is minus. So let me do that. So 3 minus 5, 5 minus 8, right? So in the next iteration, I'll increment the start. I'll also increment the end. So whenever I increment the start, right, I need to update what is the minimum start and maximum start. So if earlier the min start, earlier in the earlier step, the min start is 3, but the current minimum start is minus 5. So that this is smaller, so that I'll update it. Okay. Then just also update the max start. Earlier, the max start also 3, but the current is minus 5, so that there is no change in max start. Now, max start. So now let's find out the product of this is let's find out the product. So this is with minus 5 into current end is minus 8, which is 40. And you also have minus 5 into sorry, what is it? So max start, right? So max start is 3 into current end, which is minus 8, so which is minus 24. So out of which we will figure out a max, which is 40, which is also greater than the given max, so that I'll update the exact max to 40. So that I'll just simply, if I move further end, if I move further, so what will happen? 3 minus 5, 5 minus 8. If I increase start will come here and will reaching out of the window, so that we just return the holded value, which is 40. Did you understand? Did you understand the algorithm? Yeah, what is the time complexity? Tell me. It's a order of n. So to be precise, in worst case, every element can be visited twice. It means m minus yeah, 0 to m elements, m minus 1 elements will be visited twice. One by start, one by, I think, a few of the elements will be visited twice. Okay, so it's order of n. What is the space complexity? What is the space complexity? It is constant, right? So we take all the variables, right? So one is start, end, min start, max start, and max variable. So these are common irrespective of the given input size. The space complexity is always going to be constant. It's a simple iterative, right? It's not a recursive solution. So let me write the logic. Yeah. So what I'm trying to say, so you know start, which is starting from 0, and you know end, which is starting from m minus 1. Then we'll also have what is min start initially, which is nums of start, and what is min end initially. This is also nums of start. Perfect. Now, now we will try to move my end less than nums dot length. So you don't need to worry about start. Once you handle this, automatically start will be handled. Start should move till less than or equal to m minus 1. So you don't need to do that because you already handled through end. Perfect. So now so let's see what is the min start, whether the current value is minimum or already holded value is minimum. So let me do that. So min start, which is equal to math dot min of nums of start, comma min start. Okay, because when the current value, this is what, right? So we need to capture the minimum value also, because when the end is negative, so this will be added advantage to us. That's why we need to handle min start, and we'll also have max start, which is math dot max of whether it is nums of start or max start. Okay. So here you can declare as integer dot max value, integer dot min value, rather than that declare with start value, so that is also fine. Uh, right. So you find out min start and max start. Now let's take the current max. So how do you know the current max? So is expecting in the long value. So let me take it as a long, and I'll also take max, uh, long actual max, so which is math uh, long dot min value. Okay. Okay. So let's see here. This is my current max. So how do you calculate the current max? So whichever is max, math dot max of whether uh, min start into current end, nums of end, or max start into current end. This is what we did, right? So nums of n. So whichever is max, we will consider that as a current max. I think we need to multiply with or either you can declare. Okay, so let me multiply with 1l because it is converted to long. Do we necessarily do that? Okay, if it is giving, I think it will give compulsory error. So I'm just converting into long. Perfect. So done. So we have calculated the current max. So we have calculated the current max. Now it's time for us to update the max. Okay, so this is my max. The max equal math dot max of max comma current max. That's it. So then what we do, we will increment start plus plus, and we'll also increment n plus plus. Finally, we return max. That's it. So not find symbol min start max start. Okay, this is max start. What is the error? Yeah, I think that's only the issue. Yeah. Yeah, so that's it. So that's how it works, buddy. It's a simple, if you look at the problem statement, right, you feel like it is out of the context, but we need to understand the pattern behind that. So it's a simple sliding window problem, but if you look at as a subsequence and all, so it was a little typical, right? So let's move on. Uh, I think, yeah, let's move on to our backtracking again. Are you bored of backtracking problems, or can we move on to other pattern, or is it fine to continue 1 or 2 days? What do you think, Ajay, Kalyan? Let's do, I will try to cover next three examples. Then again, we will come back later sometime. Uh, but you need to practice, man. Otherwise, it will be tough. Okay. So let's move on. We want to find out palindrome partitioning. So let's understand what does it mean? Let's say you will be given let's say you will be given an input array. Sorry, you will be given a string A, B. So we need to find out palindrome partitioning. What do you mean by palindrome partitioning? So it means first you can divide this this string into any number of partitions of length n. For example, this string length is n. Then you can divide this string into any number of partitions, but altogether the length of the partition values is going to be n, and each value is going to be the palindrome. So we need to return all those possible results. For example, if you closely see, I can divide this into multiple ways. One is B, and I can also divide into B, and I can also divide into B. So, or I can also have B. So if you closely see, this is the same string. This is the same string. So I divided into uh, multiple partitions. But if you take the sum of each partition is having total string elements. The ask is the ask is we need to find out whatever substring present in that partition, right? Whatever substring present in that partition, each substring should be a palindrome. If you closely see, in this case, AB is not palindrome, but in this case, AA is palindrome, B also palindrome, so that this is our expected result. Okay, so we found one result, and here, if you closely see, this is not palindrome, so that I can ignore it. And if you closely look at here, in this partition, so whatever substring you see, right, all the substrings are palindrome, so that this is our expected result. Do you understand the problem statement? Okay, perfect. So simple. So you will be given a string. We need to find out all possible substrings. We need to divide this string into possible partitions. And each string of a partition should be palindrome. So this is what the expected result. Let's see how do you come up with this solution, right? So let me take into here. So you have A, B. So this is your substring. Let's say this is index 0, index 1, index 2, right? Okay. What did you understand here? One thing for sure, your partition should include all the elements present in string. And when you are making a substring, for example, this is a substring. If you see, it is a 0 to 0 substring. But if you closely see AA, if you call it as 0, 1, 2, so it's a substring of 0 to 1. If you see AAB, it is a substring of 0 to 2. But if you see other partition, which is 0, 0 and 1, 1 and 2, 2. So it means with the same index you framed a partition. Here in this case 0 to 1 and 2 2. So this is how you generate a partition. Means start index and index both are same here. In this case start is 0, end is 1, right? Hope you are following me. So this is my actually this is my backtrack call. So what I do, I'll initiate a backtrack call with 0th index and with the current list with empty list. So let me try 0 0 combination. If 0 0 combination is palindrome, yes, obviously palindrome, so that is A. So A is palindrome. As A is palindrome, I will move on to the next index. So I will initiate a backtrack call for next index 1 with current value I hold is A. So I'll initiate a backtrack call for the next index because current index is 0. Current index is 0. So I will just initiate a call with the 1 because this one. So current index is 0. I'll initiate a call to the next index. Now let's move on. Again, from the current index, I will start. It means initially you start with 0, right? So it can be 0 0 or it can be 0 1 or it can be 0 2 because it's a substring, right? Whenever you start from 0, so it can be starting with 0 0 or 0 to 1 or 0 to 2. Hope you are following me, right? Are you following me, buddy? This is more critical. Others, Ajay, Kalyan, Banu. Okay. Kalyan, are you there? Okay. So let me make it a little more clear. So you have A, B, 0, 1, 2. So first, you are initiating a backtrack call with 0 and empty subset. Okay. Now let's move on. So now it can be 0 to 0 substring or 0 to 1 substring, 0 to 2 substring because the length is 2. If it is 0 0 0 0 substring, so let's say I get A. Okay, so I get A. This is the parent and this is the current value. So this is my current value 0 1 2, which is changing, but 0 is not at all changing because it is coming from parent, right? So the second parameter is keep on changing. This is my end. Okay, so understand that. So now if you closely see, this is palindrome. As this is palindrome, I can explore furthermore. Okay, so it means when you get a palindrome, I will add that to the empty result. So you have empty result earlier. So I add it to 1. So then I will move on to the next index. With 0 0, I got it right. So I'll move on to next index. Now you have a backtrack call with index 1. So that now again you see the possibilities. It can be 1 1 or 1 2. Same concept. So here from parent backtrack how it derives, here also it will derive. Now with 1 1, see what is 1 1? It is again A. Okay, so A is palindrome. So as A is palindrome, then this is my current, this is the value which is changing, right? So this is the value which is changing. So I will take this one, I'll extend furthermore. Definitely, I will move on to the next index. So when I move on to the next index, it is going to take this backtrack call. And earlier in the parent backtrack, you have only A. So, but in the current call, you got another A. So that which is being added. Uh, So I'll move on to the earlier it is 1, right? So 1 1 you got A. So that what you do, you move on to the next index, which is 2. And earlier backtrack call already holding A. And with the current backtrack call also you got A. So that your subset becomes A. Okay, so your subset becomes A and you move on to the next index. Now you are at 2, right? So obviously you have only one possibility, 2 2, because if you reach out of that, it is out of the window. So with 2 2, what you have? B. So let's take B again. Now you have B. So B is palindrome. So that what you do, you take that you just B is palindrome so that you can add that result to the list so that and you try to initiate next call. So 3 and A and B. Okay, so because earlier you have A, right? So you got 3 A, B. Now if you closely see here, your current index, right? So this is my current index. So I started from 0, so which is reaching to the n. So whenever your current result reaching n, it means you found valid partition with possible substrings where each substring is palindrome. So that you just take that value into result. Once you take that value into the result, then what is our do? It's a traditional backtracking problem, right? So what we do, so we will just remove this, move on to its parent. Okay, so this is where it is been called. And now if you closely see from 1, you already explored 2, so there are no other possibilities, so that you remove this and move on to its parent. This is the parent which is been called. So this is a parent which is been called. We came here. So right, if you closely see from 1, we have seen possibilities of other case. Now it's time to move on to other end. It's time to move on to other end. So right, so it is 1 1 1 2, right? So I have seen the possibilities of 1 1, so let's move on to 1 2. So 1 2 means this is 1, right? So this is 1, this is what you need to see, right? So 1 2 means we will go to that, right? So listen, first follow follow this flow. 1 comma 1 a how it become a comma a? It becomes a only, na? 0 comma 1 becomes a, right? 1 comma 1 becomes a only, na? That's what we did, right? Yeah, we will explore that possibility. So now you see 1 comma 2. So it means 1 is here, and 1 comma 2. It becomes AB, right? So 1 comma 2 value is AB, which is not palindrome. So that you don't need to explore furthermore. So you can simply return to the caller. You can simply return to the caller, and from here again you will return to the caller. Whenever you are returning the caller, you remove the last element, again it becomes empty. It means you start from index 0. You start from index 0. If you closely see, first you start from index 0 and explore the 0 0. You understand that 0 0 combination is palindrome. Then you move on to the next index by adding that element, and next index is 1, so that you need to see 1 1 and 1 2 possibility. So 1 1 means you get A. So again it is palindrome, so that you move on to the next index. It becomes 2. Again with 2 2 you got B, so that you just added in each iteration, you just added the corresponding element, so that you got A B, and which is resulted. And when you are returning, you just remove the last element. And once you come back here, from here 1 1 combination is done. So when you move on to 1 2, and you understand that 1 2 value is AB, which is not palindrome, so that you just ignored and return to the parent. It means when you try with 0 0 combination, you found one palindrome partitioning. Let's move on to the some other case. So other case is what? 0 1, which means with 0 to 1, what is the value you have? So this is the value you have. So that obviously with 0 to 1, you got A. Nice. So A is palindrome. So what is your job? So you need to update this value. Okay. So you got A, right? So A is palindrome. So what is our job? So as A is palindrome, so you move on to the next index. So next index of 1 is 2. So that you just initiate a backtrack call with index 2 by updating this result into this empty subset, it becomes A. Now let's move on to the next index. So if you closely see, you have only one possibility to explore. Current index is 2. The start or end also start from the same index, 2 2. So you will get B. Now B is palindrome. As B is palindrome, so that you move on to the next index by updating the value. 2 plus 1 becomes 3, and you also update this string to this subset, or sorry, this list. It becomes AAB. So now again you see that your 3 is equivalent to length of the given input. It means you found out a valid palindrome partition. So just take that and add it. You found out a valid palindrome, so take it and add it. Then finally, you return to the caller. Finally, you return to the caller. Remove the last element. Again, you return to its caller. Remove the last element. Finally, you are done with possibility of 0 0 0 1. Now it's time to look at the possibility of 0 2. With 0 2, if you closely see, 0 to 2, if you closely see, this is the substring you get. So this is a substring you get. So obviously, which is going to be AAB, but AAB is not palindrome, so that you don't need to explore. So if you closely see, these are the two valid palindromes we got. So that is our expected result. Did you understand the flow, everyone? Others? So let me make it little clear. So this is what we did, right? So you have A, B. So initially, what is happening? I'm directly writing in the form of directions, in the form of indexes. You are initiating a backtrack call with zero and empty index. So now what it see, it could what it does, it could see all possibilities. It could see all possibilities. So possibility one could be 0 0 and 0 1 and 0 2. Okay, so now let's understand what is it is changing. So which is more important, so that you can write the logic in a better way. Now with 0 0, you see that this is our A, right? This is our A. So with 0 0, you got A. So A is palindrome. So that what you need to do, you move on to the next index by updating the current value, and you initiate a backtrack call for the next index by updating the current value to the list. Perfect. So again, you got a backtrack call for one. So what is your job? You have to explore all possibilities. So 1 comma 1 and 1 comma 2. So it means you take this call and you just see the possibilities. With 1 1, with 1 1, you got again A. Now again you understand that which is palindrome. So that what you do, you initiate a backtrack call by to the next index. So for this is the one, right? To the next index by updating the result. So earlier you have A, so you update this result. Now again you move on to the index 2, right? Now you are at index 2 now. So when you are at index 2, you have only one possibility to explore, which is 2 2. So with 2 2, you get a value as B, and B is palindrome. So that again you blindly initiate a backtrack call to the next index, because 2 here, right? To the next index, and by adding this current B to the result. Now, whenever you are reaching your index is equal to length, it means you found a valid combination. So you take this result. And similarly, if you closely see, this is what happened. So let me move this little aside. So 1 comma 2, right? So now it means again what you do. So you will do backtrack. So you went to the caller, remove the last element, and you went to its caller, remove last element, again you get it. So now you see, you have seen the 1 1 combination, you have seen the 1 1 combination. Let's see 1 2 combination. So when it is 1 2, it becomes AB, because if you closely see, with 1 2 combination you get substring as AB, and which is invalid. So that when it is invalid, you don't need to explore furthermore, so that you can simply return to the caller. Then this with 0 0 combination, you have explored all possibilities, so that return to the caller and remove the last element, you get it. Now if you closely see, this is what it happened. Now again, let me move this little aside. 0 1 and 0 2, right? Now again you need to see the combination of 0 to 1. Okay, so with 0 to 1, what is happening? So that's what more important. Yeah, so with 0 to 1, so this is what the value you get, AA. So obviously AA is palindrome. So A is palindrome, so that you just move on to the next index. So that obviously you initiate a backtrack call to the next index by updating the current result AA, because in the parent it is empty, so that you just add it. So you went on to the next index, which is 2. So which is 2. So obviously you try C to see only one possibility, which is 2 2. So again you get B, and again you initiate a backtrack call with the next index, and you take A and current B. and obviously this is reaching to the length of the array. So you take this value and store to the result. So again, you found one more result. Again, you do the backtrack. So that's how it went here. And finally it come here. So it's going to be AAB, which is not palindrome, so that you don't explore. So these are the two possibilities, you get it. Now, hope you get it right, everyone. Banu, Ajay, Kalyan. Okay. So now let's let's see the time complexity. Let's see the time complexity. So to know about time complexity, we need to understand how many valid palindrome substrings we could get, right? So we need to understand that. So this will clarify the time complexity. Based on that, we can derive. So let's say you have a. So let's say you have a. So if you start from 0, 0, obviously you look for 0, 0, 0, 1, and 0, 2. So if it is 0, 0, you get a. Again you look for again you look for 1, 1, and 1, 2. So this is what it happens, right? Again 1, 1, you get a. Again you look for 2, 2, and 2, 2, you will get a. And if you go for 1, 2, again you get a. Uh, so again you get a. So that's it. So you are able to done with because the length is 3 only, so that you get a. Now again, uh, if you closely see 0 to 1, so 0 to 1 means this one. So that obviously you get a, and you move on to index 2, 2, because this is plus 1, right? So again you get a. Again you see 0 to 2, so it is a. If you closely see, these all are the recursive calls we had, and if you closely see the possible palindrome substrings we could see, one is a. This is also substring, and you also see a comma a and a comma a and a. So if you closely see all these all possible substrings, right? So you get a. So this is also valid partition, and a comma a. This is also valid partition, and a, and this is also valid, and you have a. So let's understand how many possible palindrome substrings we are generating. Okay, so if you closely see, this is 1, and this is 2, and this is 3, 4, 5, 6, 7. So it means we have n equal to 3, and if you consider this also with empty, it becomes which is n equal 3. We closely generated 8 substrings, and all are palindrome. All are palindrome. So all palindrome. So that if n equal to 3, it means we generated 8. So which is going to be 2 power n substrings we generated. So because 2 power 3 equal to 8. So we generated 2 power n substrings, and we are also copying the result into the current subset. So obviously the length of this substring in worst case, which is n, so that obviously the time complexity is going to be n into 2 power n. Understood? Understood, buddy? Okay, so what is the space complexity here? What is the space complexity here? Let's talk about the stack frames. So let's talk about the stack frames. So with respect to stack frames, if you closely see, at any cost in time, only n stack frames gets active. So obviously the stack frames time complexity will be linear, and the result, right? The result, it's very tough to calculate. I'm giving it to you, man, so you can explore on it. Even if I say something, I'm not sure how valid it is. Uh, this is how it is. So let's move on. Let me write the logic. Somewhere it was there. Okay, so what is our job now? So first, we are going to initiate a backtrack call. Uh, so what I'll do, I'll also store a result. Array list. Okay, so I'll initiate a backtrack call. So I'll get the index. I'll also get string, yes, and I'll also get a list of strings, which is current list, you can say. Okay, so now, uh, yeah. So now let's see the base case. So whenever your index is equivalent to s dot length, it means your sublist, whatever list you have, which is already holding the result. So you can simply add to the result, add of new array list of current list, and you don't need to explore further. So done. So obviously you don't need to write a return also, but that's fine. Now let's move on. Uh, this is my for loop. This is my for loop. So let's say I'll call it as a start rather index. I will start call it as start. If you closely see, every time you have when you call from here, start is 0, end is keep on changing. First time 0, second time 1, third time it is 2. So how does it work? So this is my end, which is equal to start. It is initially starting from start, and it is moving till s dot length and n plus plus. Now, what is your job now? First, you will check. First, you will check is palindrome palindrome of given string yes with the given start and given end. So if it is palindrome, what you do, you take that result and add it to the current list. So what you do, so current list dot add of s dot substring of from the start and end. You just need to do end plus one, otherwise it will ignore the end value. So that do end plus one so that it will consider end value. So perfect. So you add the current substring. So we will write this palindrome logic and current substring, you add it. Then you initiate a backtrack call to the next one. The backtrack of next one is going to be n plus one, correct? So that's what we did, right? If you closely see, this is what we did, right? So this is 0 earlier, sorry. Yeah, so closely see, this is 0 earlier. So we added the result and we called 0 plus 1, so it becomes 2. So again, when it is 1 and we added the result and we added 1 plus 1, so which is becoming 2. So that's what we are trying to do. So same thing. So here we do n plus 1 and given substring and current list. So once you explore all possibilities, what is our job? So a traditional backtrack logic. So we remove last element. Perfect. That's it. So done. So we are need to update this is palindrome logic. Boolean string yes in start and in the end. So yeah. So well, let's write while start is less than end. If s dot caret of start not equal to s dot caret of end, then you will return false, obviously. Otherwise, you will do start plus plus and minus minus. Finally, you will return true. So it's a simple palindrome logic. And let's move on. What is our job? So we just need to initiate a backtrack call with index 0. With start index is 0. Then with the given string and new array list and return a result. That's it. So if you put pen and paper, definitely you will get backtracking is not very complicated, but the thing is you need to get that hint. It automatically solves. Okay, so that's how it is. Let's stop for today. Hope you like it.